This is topic 1.3. Now, what we're going to do today is we're going to spend a little bit more time learning how to actually convert between radians and degrees. In the last lesson, you saw that I threw that out as an option that you can use to try to continue to understand what is a radian. But the actual skill of converting is really required for us to proceed and get a little closer to trigonometry. So I want to actually take a period and make sure that we understand this skill. In fact, it's actually not that hard to do, even though it's such an important skill, because it's always going to use the same ratio. And the ratio that we use is to say that pi is to 180. Now, understand mathematically what I'm saying here. If you have pi radians, that's the same as 180 degrees. And if you're still saying, what do you mean pi radians? Pi is a number. It's just about the number 3. That means if I have 3, those angles that we created in the last lesson, if I have 3 of those, that's the same as having 180 degrees. But we use that ratio as basically our conversion factor. Now, when I say factor, I literally mean we're going to be using a factor label method. The factor label method gets stolen from your chemistry class. If you've never used it, you'll learn today that it's really easy to use for converting. And so let me just jump right in here and let's kind of do an easier degree. How about like 30 degrees? Let's say we want to convert that to radians. Now, to convert that to radians, using the factor label method, what we do is we kind of set up this chart. But what it really is a numerator and denominator. In the numerator, you will always put the label. You will always put the version that you're trying to convert to. So I'm trying to convert to radians. I'm going to put pi in the numerator. Now, since pi is to 180, 180 is the only thing that can match with that. But the idea here is that I have a label of radians in my numerator, and it turns out I have a label of degrees in the denominator. Remember, you always put the label that you're trying to convert to in the numerator. Now, in the factor label method, there's this concept that I want to cancel the other labels. The other label is degrees. Well, that means I need to cancel degrees, and the only way to cancel degrees is to put something up here in the numerator, degrees, that will cancel with it. And of course, what I put is 30 degrees. Now, like I said, this is really just a fraction. And so mathematically, fractions can cancel. That is, numerators and denominators cancel. So what I do is I cancel out the degrees. But what I also do here is I discover that I'm really just now multiplying 30 times pi and dividing by 180. And so I get 30 pi over 180. Now, before you get your calculator out, we actually want to simply simplify this fraction. That is, we want to simplify the integers. So what I want to think about is really, how do I reduce 30 over 180? And I hope that you would reduce that, divide or reduce it 6 times by realizing that 30 can divide into 180 and reduce to 6, which ends up giving us pi over 6. Now, pi over 6 is in radians. In fact, it is a radian. And the truth of the matter is that 30 degrees was discovered a couple days ago to be the same as pi over 6. So maybe you remember, in fact, you can even get it back out, that we said that if you're at 30 degrees, that's the same as pi over 6. Let's try another one. Let's convert 265 degrees to radians. Now, 265 degrees is not a sort of a common angle. Therefore, we don't really know what the answer is already. So we're going to set up this factor label method. We're going to put radians in the numerator, because whatever goes in the numerator is where we're trying to go, what we're trying to convert to. And, well, it's always pi matching with 180. Now, it's 180 degrees, and so I need to cancel the degrees. The only way to cancel it is to put a degree up here in the numerator. Well, that would be 265 degrees. Honestly, it works the same way every time. The degrees cancel, and I end up with 265 pi over 180. Now, again, before you get your calculator out, all you really want to do is think about reducing these integers. So I'm going to reduce 265 and 180. Now you can start reducing by fives. You can start, I would start with fives because 265 is definitely divisible by 5. And of course, anything that ends in a 0 is also divisible by 5. That ends up being your reducing factor. If you reduce by fives, you get, I believe, 53 and 36. I want you to see the way that I wrote this, though. I wrote it as 53 pi over 36. Now, often at this point in the lesson, students are like, what is that? What is 53 pi over 36? Well, it's a radian. But what it's really referring to is an amount of radians. Literally, 4.6 radians. Now, the angle that you made in that activity, if you have 4.6 of those, you're going to wrap your way around to 265 degrees. Okay, because to wrap around to 265 degrees would be in this area. And to say that that's the same as 53 pi over 36, which is the same as about 4.6, should make sense. Why? Why should it make sense? Well, remember, one of your checkpoints, one of your four corners is 270 degrees. And 270 degrees is the same as 3 pi over 2. And 3 pi over 2 by a decimal is 4.7. So wouldn't it make sense that to be at 265 would be 4.6? Okay, so these radians, it's a new way to measure. Okay, it's a new way to measure, but it really just refers to an amount of angle. Now, that's converting to degrees. What if we want to convert the other way? What if we want to convert, excuse me, I said that backwards. This is converting to radians, but what if we want to convert the other way? What if we want to convert to degrees? And honestly, that's usually a little bit more practical, because if we want to convert to degrees, it's probably because I gave you something in radians. Now, 7 pi over 8, that's a radian. Most students, if they're honest, will say, I don't really understand what that is. I'm trying to understand it, but I need some help. The place that we usually go for help is back to degrees, because we understand degrees. So we're going to use the factor label method. Now, when we use the factor label method, you're still going to use the ratio that pi is to 180. Here's the one difference. You're going to put 180 in the numerator, because that's what I'm trying to convert to. Remember, whatever you're trying to convert to, whatever your outcome is, whatever your goal is, that goes in the numerator. My goal is degrees. Degrees in the numerator, and now I'll put the pi in the denominator. That means what I want to do is I want to cancel the label radians. Now, when I cancel the label radians, or should I say I will cancel the label radians when I put that in the numerator, because rules of math say that a numerator and denominator cancel. Okay, now what we're looking at here is a little bit of a fraction, and the fraction says that I've got some stuff in the numerator and I've got a pi in the denominator. Well, if you look carefully, you also have a pi in the numerator, which by rules of fractions will cancel. And so it looks like that all I'm really ending up with here is 180 times 7/8. Now, a lot of students will ask, is that always going to happen? And my answer is, or my question back to you is, what is always going to happen? Are pi's always going to cancel? Well, as long as you have one in the numerator and one in the denominator. Okay, now what I'm not saying is that you're always going to have that. But what I am saying is that if you have them in the numerator and denominator, they will always cancel. And we have a pretty easy math problem here. It's kind of like we're just trying to find 7/8 of 180. And 7/8 of 180 is 157.5 degrees. 157.5 degrees. Now listen, this goofy 7 pi over 8, although I'd like it to begin to not be too goofy, is just the same as 157 degrees. We all know that 157 degrees is somewhere over here. Well, guess what? That's the same as 7 pi over 8. Now, 7 pi over 8 is also a number. I'm not going to do this every time, but that's equal to about the number 2.7. That means having about 2.7 of those angles you made in that string activity, okay, would get you in the same location. Let's say you want to convert negative 2 pi over 3 to degrees. Negative 2 pi over 3 to degrees. This might be a part in a lesson where you feel like you want to try this on your own. If you do, then push pause. If you'd like to see me work out another one, then I'm going to show that now. We're going to use the factor label method. We're trying to get an answer in degrees, so I'm going to put degrees in the numerator. To keep the ratio, pi now goes in the denominator. So 180 is to pi. I want to cancel the radian. The only way to cancel the radian is to put a radian in the numerator. Now, the label radian cancels. By the way, you really don't have to show this. Okay? Why do you not have to show it? Because we really don't have officially a symbol for radians. If I write out the word radians, it helps us to see that it cancels. Okay, but it's going to happen every time. Now here's this pi in the denominator canceling with pi in the numerator. Yep, as long as they're both there, they're both going to cancel. So what am I trying to do? I'm just trying to take 180 times negative 2/3. Kind of like trying to find negative 2/3 of 180. It's 120, check that, negative 120 degrees. Negative 120 degrees. Now, do we understand what negative 120 degrees would be? Okay, we're trying to understand that. First of all, negative rotation goes this way. You go past negative 90, but don't go the whole way to negative 180. So this angle would be negative 120. But I want you to understand that that's the same as negative 2 pi over 3. Okay, it's the same sized angle. Now, in closing, what would you do if I asked you to, let's see, I need some space here. Just gonna get rid of some stuff in the middle. What would you do if I asked you to change 4 radians to degrees? Basically, what would you do if I asked you to understand or show that you understand where is 4 radians? How big is it? Where is it? How do you turn it into degrees? Okay, now if we were in class, students might be using some different strategies at this point. A common strategy would be to do the same thing we just did over here. And the truth is, it works. As long as you do correctly, as long as you understand that you cannot cancel the pi because, well, there's not a pi in the numerator and denominator. So now I'm looking at 180 times 4, which is the same as 720 divided by pi. Now, 720 divided by pi, if you work that out on your calculator, it comes out to be 229 some degrees. 229.2 degrees. Okay, it's not like a common angle. Okay, but maybe you're a little unsure. Maybe it just seems like something's not right. Remember the first day we said that a radian is the same as 57 degrees? Well, all we're really doing is saying here that we have 4 of those 57.3 degrees. We have 4 of them. So to have 4 radians is to have 4 57s. Well, guess what? That comes out to be 229.2 degrees. Okay, so a radian, it's an angle. It's about this big. If I have 4 of them, I'm going to be at 229 degrees. If I have 7 pi over 8 of them, I'm going to be at 157 degrees. So a radian is just an angle, and to describe it is to, or maybe I should say to understand it, is often to convert it. And we can convert it with a factor label method. Okay, now this should help you to be able to work through the homework helper where we're purely doing converting.